All right, so today we are going to be talking about absolute value equations. So you may remember absolute value. For example, the absolute value of 2 is 2. Also, the absolute value of negative 2 is 2. All absolute value is just the distance the number is from 0. So since distance is always positive, basically a positive number stays positive and a negative number is just going to turn into the positive form of that number. Right, so let's look at an example here. Say, for our first equation, that the absolute value of x is equal to 5. All right, so a very basic example to start here. The way we would approach this, since we're going to have two solutions, so you might be able to look at this and say, well, it could either be, x could either be 5 or x could be negative 5. And you're right. The way we're going to set these equations up when they get a little more complicated is we're going to take whatever's inside the absolute value and set that equal to what's on the right. And then we're going to say the opposite of whatever's inside the absolute value is also equal to whatever's on the right. Okay, so this first one is already solved for us, x equals 5. The second one here, so this is just saying the opposite of x is equal to 5. So the way I would solve for x would be to divide by negative 1. So we would say x is equal to 5 divided by negative 1 is negative 5. So we have two solutions here, 5 and negative 5. When we solve these absolute value equations, we're going to be putting our solutions on a number line. And this will be handy when we start solving inequalities in the next lesson. So I'm just going to quick make a number line here. So this would be 0. Okay, and I just have to make sure negative 5 and 5 are on here. And since those are my solutions, I would have a dot at negative 5 and a dot at 5. All right, so let's look at some examples with a little more to them. So here we have the absolute value of x minus 2 is equal to 3. All right, so we start this the exact same way. We're going to take whatever is inside the absolute value and set that equal to whatever is on the right. In the same way, we're going to take the opposite of whatever's inside the absolute value and set that equal to whatever's on the right. So, for the first equation here, I would add 2 to each side, and x would be equal to 5, and that's my first solution. On the other side here, I could do two things. I could either distribute that negative, or I could divide by the negative. So, we'll look at both ways. First here, let's look at distributing. So think about this as being a negative 1. So negative 1 times x would be negative x. Negative 1 times negative 2 would be positive 2. So I would subtract 2 from each side. And divide by negative 1. So my solution would be x equals negative 1. Then I would want to graph that on a number line. All right, so I have solutions at negative 1 and 5. All right, let's look at an example that adds just a touch more here. So I have the absolute value of x plus 1 minus 4 equals negative 2. All right, so the difference here is we don't just have the absolute value on the left. Before you can proceed and set what's in the absolute value equal to what's on the right, you have to get this absolute value piece by itself. Okay. So for us, that would mean we're adding 4. So we have the absolute value of x plus 1 equals 2. All right, so now we can say x plus 1 equals 2, and the opposite of x plus 1 equals 2. So x here, when we subtract 1, would be equal to 1. And on this side, now I'll show you the other way. Instead of distributing that negative, we could just divide by a negative 1. So we would have x plus 1 equals negative 2. And then subtract our 1 from each side. So we have x equals negative 3. Don't forget we have to graph that. So we have solutions at negative 3 and 1. Look at another example here. It has even something more to it. Okay, so notice this time we have a number out in front of that absolute value. So still the same as the last one. We're going to have to get this piece by itself before we can set up our 2 equations. So I would start by adding 5. So I'm left with 2 times the absolute value of x minus 1 equals 6. All right, now I'm going to divide each side by 2 to get rid of that 2 that's out in front. All right, now I can set what's in the absolute value equal to 3, and the opposite of what's in the absolute value equal to 3. All right, so here I would add 1 to each side. We would get x equals 4. And over here, I'm going to go ahead and divide by negative 1. So I would get x minus 1 equals negative 3. Add my 1 to each side. Get x equals negative 2. So when I draw this on the number line, we have solutions at 4 and negative 2. All right, so another example here. This time we have the absolute value of x minus 3 plus 4 equals 4. Okay, so first thing I want to do is get that absolute value piece by itself. So this right here. So I'm going to subtract 4. So I have the absolute value of x minus 3 equals 0. So x minus 3 equals 0, and the opposite of x minus 3 equals 0. So on the left, we have x equals 3 when we add 3 to each side. Over here, I'm going to divide by negative 1. So I have x minus 3 equals 0. Right? 0 divided by anything is just 0. Now notice that these are the exact same. Right? So our solution, we get x equals 3 each time. So we just have one solution for this problem. And that's because our absolute value was equal to 0. Okay? And the distance from 0 to 0 is just 0. There's not 2 different ways there. You can't go positive and negative for just 0. So when we graph our solution, we would just have 1 dot at 3. All right, last one here that we're going to look at. X, absolute value of x plus 2 plus 3 equals 1. Okay, so first thing I want to do is get the absolute value by itself. So I'm going to subtract 3 from each side. Okay, now at this point, we should notice that absolute value is equal to something with a negative. Now, since absolute value is the distance from 0, like we said in the beginning, a distance can never be negative. So if you ever encounter absolute value, doesn't matter what's on the inside, is equal to anything negative, that's not possible. Okay? Absolute value is never negative. So for this problem, we say for a solution that there is no solution.